Hello everyone, welcome to Engineers Palette. I hope you all will be doing well. Today we'll be starting our next tutorial series that is about game. First we'll be studying Solidworks game, and then we'll move to other platforms like a Fusion 360 for advanced game. So what is CAM basically? CAM is computer-aided manufacturing in which you use computer or microprocessors, post processors for uh, generating tool paths and control your machining. But basically, CAM is a computer-aided manufacturing in which you use your computer, your uh, CAM softwares, in which you use your CAD model and generate its tool path and all its G and M codes for its process and production. It involves computer softwares which generate its manufacturing process paths or which we call the codes. We'll study that in details that how you can completely generate your parts or your products G and M codes for CNC machining. Okay, so what are the key components of a CAM? The first one is CAD. Without CAD model, you cannot perform your CAM activities or CAM. You cannot generate your CAM codes. Okay, whatever you want to design, for example, an aircraft engine parts or any other thing, like for example, if you want for even for a 3D printer, it will ask you first to make your model in a CAD model. Okay, so whatever part you want to you want to manufacture, you will need its CAD model. When you construct your CAD model like this, then you will generate your tool path using CAM. That is basically sometimes like for example in a Creo or in a Solidworks, there are integrated CAM, or even in a Fusion 360, or you can use some softwares like which are uh, uh, made for CAM like Master CAM or solid cam. They are completely cam softwares, but you can also use your modeling software like a SolidWorks or Creo or Katia or Fusion 360, in which you can generate a tool path for your tool uh, to construct your or to manufacture your part. For example, in this example like here, this pocket or this profile, these are the lines. These shows that this your tool will move along these lines. These will be your passes means that how many times your tool will pass through this uh, complete area this complete area to totally construct your part. So we'll study these tool paths in details, and we'll construct them in our tutorial series. And the next thing is CNC, the computer numerical control or machining. Is a CNC machine that we called. CNC machine is basically your lathe machine, or it will be a milling machine that's manual milling or um, a manual lathe machine. You just integrate your post processor here, that is the machining interface, and all these functions that you can do with manual lathe or manual milling machine. The CNC machine can do it automatically, and it can do some more it can perform more critical and complex parts and complex features that you cannot produce with by using your manual CNC machine, manual lathe or milling machine. Okay, so next one is G codes. That you use your CAM to produce your tool path, and when you you can produce your tool paths, and you can select your tools for any manufacturing process, for manufacturing of any part. But when you go and produce them in actually in a physical shape on a CNC machine, you will need GNM codes. So basically, what are GNM codes? When you perform your game, you end up with generating post processor codes, which is in the shape of your programs. It precisely mention all your dimensions that your tool path will follow to manufacture that part. So GNM codes are basically uh, those are basically the cause from which your program is complete your program is made. Okay, so what are first we'll study what are G codes. So G codes are basically those codes which control the movement and the position of the tool paths along various axes of machine. For example, it could be 3 axes or 2 axes or maybe 7 axes, 9 axes or 5 axis machines or advanced machines. uh, um, and these G and M codes, they control the movement of your path, the movement of your tool along these axes and position of them. For example, G00, yeah, GOO is a rapid positioning. Rapid positioning means that if you put GOO and then you give your axis position, for example X10, Y20 or something, so it will rapidly move your tool to that position. And then there is a G01 linear interpolation, mean the movement will be in a straight line. So linear interpolation, in this your tool will move according to the feed you have provided to your tool. Okay, then G02 is a circular interpolation clockwise, and G03 is a circular interpolation counterclockwise. Means if you have something like a round shaped or circular shaped, or like for example a fillet, so these circular interpolations are used there. It depends upon your tool and your required shape, that in which direction your tool shall move. For example, if it is in a circular interpolation clockwise, you will use G02 code. Or for example, if I'm using if I want my tool path to my tool to move from x00 and y00 to x10, y10, and the radius of my curve is for example 10 millimeters, and I need to follow clockwise interpolation, then I will use G02 x0 sorry my tool's initial position is x00 and y00. So if I move to um, x10 and y10, I will give x10 then y10 and the radius of that, which is a 10. Okay, so this is how you can use. We'll study that in more details. Then there comes M codes. So M codes are basically used for a miscellaneous functions. For example, if you want to turn on the spindle or turn off the spindle, or you want to activate your coolant and other functions. For example, if you want to turn on the bulb or light inside your CNC machine, or you want to lock your um, doors or unlock your doors, so these all functions can be controlled by M codes. For example, MO3, so spindle on and in clockwise direction, and MO4 spindle on an anti-clockwise rotation or counterclockwise rotation. Okay, MO5 means spindle off. That means that your spindle will be off, stop rotating. And then MO8 is a coolant on, like MO8 and MO7 both are coolant on. One is a mist and one is a flood, and many other functions that GNM codes are performed. Okay, then we have a types of CNCs. The first one is CNC turning, or in conventional language we use that lathe. Okay, so in CNC turning, your job that you want to construct will rotate and your tool will be stationary. You can give a feed to your tool, but but your tool will not, like in a CNC milling, that we'll study later on this topic in this tutorial, that is actually moving. But in CNC turning, it means that if you want to construct some circular geometries, if you want to draw some threads along something, so you use your it means that in all direction the geometry will be uniform in a circular direction, in a circular pattern. So you use a turning lathe. The other one is milling. Milling means that your job that you want to construct will be stationary and your tool will be moving. Like in this picture you can see that this is an end mill, and it is moving, and it generates this part. So basically you can create more complicated shapes by using CNC milling machine. Like for example CNC that is written in this picture, so you cannot construct this by using your CNC turning or lathe, because it is not rotating. You will use your tool more movement to create these grooves here, but you cannot produce that with a CNC turning. Then there comes CNC mill turn. Mill turn mean that sometimes in a particular, like a milling, the job is for turning, but you will need to construct some slot, or you will need to add some circular hole inside your job. So you will use both of them. Like first you can create your geometry by using your the turning first, and then there are gang tools, or we call it a live tool, that construct some patterns like this along um, your job. Okay, so this is the other type. These are three main types of a CNC. Then the advantages of came, so it provides you more precision and accuracy. For example, if you use a conventional lathe, you will have a drawing, but if you use a conventional lathe or a milling machine, you can't achieve that precision in a conventional milling or lathe machines. But using CNC machines, or for this you use a cam. So in cam they calculate complete, like a thermal compensation and tool compensation and everything, and they calculate that, and then they provide more precise dimensions and more precise tool paths to your to construct your uh, part that you want, and provide more precise code that you can insert into the post processor of your CNC machine, and um, generate your and produce your part. Okay, efficiency in production. Obviously, if you have a more precise and more accurate code for construction of your parts, then the efficiency of in production will also increase, because you will have a less number of defected parts. And reduction in human error. Obviously, if you use a manual CNC, like turning or milling, you will the human error will be more, because an operator will obviously operate that machine and the complete cycle of producing any part. But in a CNC machine, operator just need to provide a stock and look after the machine. The machine itself, using that code with the help of a post processor and all automated functions, generate your part. And application of SCAME are worldwide, in every field, like for example aerospace and automotive industries. It is used in mm, so many, like uh, it's used in various industries, like in aerospace. For example, if you want to construct some airplane parts or automotive industries parts, you will use came, because these parts are quite complicated and you cannot construct it by using a manual um, machines. Then a customized product manufacturing. If you want to customize some material with according to your um, use, then you will use automatic CNC machines or CAM. And the prototyping and mass production. If you want to uh, produce new parts, you first need to generate its prototype. So for prototype, you obviously um, need to it's production plan. So for a production plan, obviously most of the parts are constructed by using CNC machines, mostly CNC milling. So you will need a cam for that. I hope you would understand the basic of it, and then we'll move to the in the next video tutorial we'll move to SolidWorks cam, and we'll start that how you select your stock material and generate your some we'll start from the basic and we'll move to advanced. We'll study both turning and milling and then the mill turn combinedly. I'll see you in the next video. Please like and share with your friends and do subscribe to our channel. Take care.